All right, we're going to be working on Module 1, Lesson 11, talking about scale drawings today. Example 1, for each problem, part A is the actual picture, part B is the drawing, and it wants to know, is the drawing an enlargement or a reduction of the actual? So, since this is the drawing and it's getting bigger, we call that an enlargement. And in number 2, notice this one is getting smaller, so we call that a reduction. So let's think about some examples of where you would see enlarged drawings or reduced drawings. Think about science class. When you're looking at something in the microscope, you're going to see that image larger than it actually is. So anything you look at through a microscope would be an enlarged, and a lot of times you draw what you're seeing so that you can study that. A reduction might be often we see it as a map. You can't actually draw these streets the same distance that you see it, or the same distance that it actually is. So we reduce the size and we use a map. So that's a popular reduced drawing. Now, both of these are called a scale drawing, which is when you take a picture and you either reduce it or enlarge it so that it can fit on a paper and it's easily to work with. Example number 2 is on the next page. Derek's family took a day trip to a modern public garden, and Derek looked at the map of the park that was a reduction of the map located at the garden entrance. The dots represent the placements of rare plants. The diagram below is the top view as Derek held the map while looking at the posted map. Point V does not correspond with point R. Correspond means that it lies in the same position. So if we're looking at point V, it's not in the same position as R. Even though it looks like it is in the same position, it is not. And that's because this map is not corresponding fully to this map. Because if you turn this counterclockwise, that's going to be your where they are lined up. So point V does not line up with point R because we can say the map is not in the same direction. You can even notice the circle and half circle are not in the same positions. So let's actually turn your paper and you can see point A here would correspond to, if you were to turn it around, that would actually be point R. Point V would line up with point W. H would be point P. And Y would be point N. So you have to have them all corresponding to the correct points. Now let's look at it from an angle that we just finished talking about, this whole idea of constant of proportionality or unit rate, because when you're talking about a scale drawing, they should all be increasing at the same size. All sides should be, or decreasing at the same side, at the same constant rate. So let's take a look at this. This is our original drawing, and then we made a second drawing. So the original drawing, the height goes from all the way from 0 up to 18. And the width, if I count it out, 1, 2, 3, 4, 5, would be 6. The second drawing is 9 and 1, 2, 3. So there's my distances. Now let's see if it's going up at a constant rate. Now remember, to find the constant of proportionality, we're going to do y divided by x. So for height, it would be k equals y is 9, 18 is x, which would be 1/2. Now let's see if the length is the same. Y is 3, x is 6, which would be 1/2. So my constant of proportionality is 1/2. Now what that means is that it is being reduced by half the size. And that is being reduced by half the size. Let's take a look at this exercise. What I'd like you to do is pause this video. Try this exercise on your own, and when you're done, press play again and see if you are correct. All right, for this one, we have two triangles, the original and the drawing. Let's first fill in their actual heights and widths. So for the height of this drawing, 1, 2, 3, 4, 5. The width of this drawing would be 3. The height of this one would be 15. The width would be 10. So let's see, if this is x and this is y, let's see if the constant of proportionality exists. So y divided by x, this would be 15 divided by 5, so that's a 3. And the widths would be 10 divided by 3, which is 3 1/3, which does not equal 3. So no, there is no constant of proportionality because the unit rates are not the same. Is Luca's enlarged mosaic a scale drawing? And no, it would not be, because it has to be increased at the same rate. This is not being increased at the same rate.